All right. Do we have sound into OBS? Looks like it. And that says that we're good there. Cat distractions for a little bit here, it seems. All right, here we go. All right, I did not make it on over the weekend. Ended up being busy this weekend and wanting to do some other stuff, but the stuff that I did do some stuff that I will now get to work on the code for here on stream. So I was not necessarily in a position to stream or record the work that I have done, which I'll show you over here. Newest Cardboard Arcade, although this one's not really an arcade game as much as a more like an implementation of an existing game. So yeah, this will be the first stream on this. I have talked about this one before if you frequent the meetings, or I probably mentioned it on streams and stuff a couple of times. But I don't think I've ever done any of the work for it on the stream because I was trying... Dang it, buddy. All right, I'll be back in a minute. Okay. I kind of got the idea for this a while ago, and I started going down one road for hardware, and I didn't really like where I ended up, so it ended up tabled for a while. I was working on some other stuff, and I was brainstorming different ways to do the hardware, different ways to do the wiring. How's it going, Tyth? Yep. Oh yeah, he's fine. He's just messing with some stuff. Knocked what it was is a tape player that he knocked out of a bucket, basically. And so I have finally ended up finding something that I like. It's kind of dark in there, I suppose. We can put the light on. There we go. So I ended up with alligator jumpers. So it's alligator on one side and then kind of like just a breadboard jumper wire on the other side. Obviously the arcade buttons. And then what I have is a proto breadboard, the one that you get if you have an order that's over a certain amount. I don't know exactly what the amount is. We'll go breadboard proto. This thing. So I have a perma proto breadboard. I soldered some female headers to it on the bottom side facing outward. And then I also soldered some female headers to it on the top side, which the feather can connect to. And then there's like, I can't show it necessarily super easily, and I don't want to take it apart right now. Eventually I'll probably take it apart again for some more photos. So there'll be photos eventually of it taken apart, but there's kind of like two slats cut in the cardboard there for the female header pins that are sticking out the top side of the breadboard. And then the feather can plug into that. And then obviously on the bottom side, I've got some more female headers, which then those alligator jumpers plug into. So it's all like part of my kind of like, I don't know, self-imposed design restraint, I guess. Constraint? Not restraint. Yeah, constraint is, I like the idea of like this kind of fully reversible thing, I guess. I've always found it challenging to like really commit a piece of hardware to a project. So I like this idea. I use a lot of kind of female jumpers, or I should say rather female headers, in order to be able to connect microcontrollers to, and it's reversible. Obviously, you can just unhook it. The buttons in this case, nothing is permanently connected to those either. Those are just alligator jumpered in. So like I can kind of take this whole thing apart and reuse all these components for something else, which is kind of a way just that my brain works essentially. When it comes to designing stuff like this. The way I will mention real quick before I jump right into some of the other stuff, one of the things I looked at, which I didn't end up going with, what are those things called? It's not stemma, it's the, what is the other little 4-pin connector? that's not stemma, Grove. Yeah, this thing. So at first I was looking at this thing and having it combined kind of back to back with a reverse feather TFT, which allows it to fit together nicely with this so that these things face out one side and the screen is on the other side. But what I found is the wires that go into these are like very small, a little too flimsy for what I need, and also too short, basically. These are the ones, it's only 100 millimeters long, which I guess on paper sounds like it might be kind of long, but in practice, it was relatively short. I was having trouble actually being able to reach the button, and then I was going to have to figure out how to solder some kind of extender into the case. And what I found is when I did try hooking up one of these with an actual button, I was not getting solid signals. It was kind of working sometimes if you held it just right, but it was not working all the time if you weren't just holding it perfectly still, holding it in just the right position. So I was having trouble getting solid connections, and I'm hoping that with the new one we're going to be good to go. I have not tested all 4 buttons, but I have tested one of them, and I got some results that seemed promising to me to make me think that probably the rest of it's going to be okay. Okay, so that's a little bit of the backstory, and then in terms of what I'm working on right now, we're about to jump in right to the code. I have not really written any of the code for this just yet, which we can't do until we plug in. Let's get this plugged in. Hopefully that wasn't too loud. Didn't mean to punch the microphone there. Okay. I may eventually cut another hole in the top of the box, like around here somewhere, where this wire could then kind of like tuck down into that hole. And the way the box works, there's actually a short side over there where it can come out of. But for now, I'm just going to plug it in over the top. And I'm not sure about the hole. I kind of don't mind the cord just hanging off the side there. I know it doesn't make it look as clean, but it, I don't know. The hole, it would be hard to feed the wire back and forth through it and all that kind of stuff. I don't know that I really want to do it, but it's an idea, and it's something that I may do. Okay, right now is only test code, which lights up A0 whenever D5 is pressed. So everything is all wired physically in the circuit, but the only things that are actually in the code right now is one LED and one button, and the only code that it's doing right now is when the button gets pressed, when the button is pressed, the LED will turn on. And when the button is not pressed, the LED will turn off. And I believe it's this one. Yeah, and you can see the glow there. However, we may need to go back to no light. Let me see what that looks like without the light on. Yeah, it's kind of a lot easier to see. Okay, I think we're going to stick with that because I'm actually got the camera and the microphone are kind of in, like blocking my direct view of the top of this thing. So I'm kind of going to be relying on the view here to see, and I want to be really clearly seeing that. Eventually I'll be putting some stuff on the screen, but it won't be for a little bit. And the first thing I want to do is, I think I want to take a crack at, where'd my other Learn Guide go? Lose my Learn Guide? Do I have a tab open to learn? One of the things I want to try to do with this project is code it with async.io. I don't know for sure if it's going to turn out, but it's kind of an idea I want to try and see if we can make it work well, because it would be nice to have a sort of like, you know, it's not super duper complex, but it's kind of medium complexity project to point to as an example. The main page that I would like also is this one, I think, communicating, because we're definitely going to need to be doing communicating. So we're going to be able to like create a state object Our state object is going to hold more stuff. This one just has a interval value. We're going to probably have like all the state the game needs, like what level you're on. I don't know if I mentioned it, but the game is kind of a Simon type game where it's going to light up the buttons in a particular order, and then you have to try to follow the order that the game chose randomly. And if you get it correct, then you go to the next level, and it's harder. It adds an extra button press, and it gets a little faster. If you get it wrong, then you lose, and it starts over if you want to play again. So in terms of state, I'm thinking for sure things like the current level that you're on, which basically represents, how long the sequence is going to be. That's going to be part of the state. The speed, and the speed might actually be two values, one for the amount of time the light spends off and one for the amount of time the light spends on. Both of those will work together to create the speed, and we'll probably lower them over time to make the game harder as you progress. Okay, so this one has the interval state. It starts it off on half a second, and then the button task, I'll call it a task. I don't know if that's the right name, but I think it is, right? Canceling task, concurrent tasks. I think that's a task. The button task will change the state on the interval object. You do pass the interval object into that, okay, and also into that one. So we'll be passing around our game state. Pin. This is this is interesting. It's actually creating. It's like creating and destroying the digital in-out object every time this runs, which is kind of crazy, right? Interesting. I wonder if there's a specific reason it's doing that. I feel like, isn't it? It's more typical, I think, to just you would create this once, kind of at the beginning, and then use it the rest of the time. Okay. So we're going to have a very similar structure here. It's not going to be the exact same, but it is going to actually be pretty similar. I'm even going to grab this, throw it there. Wish I could collapse that up. Maybe we'll just take the code, I guess. So that's async IO example code. What I want to do is split that and then give me that with CodePy. Keypad? Yeah, I guess we'll use keypad. Digital I already have this stuff. Okay, so we will make a class. I'm just going to call mine, I think, GameState. GameState. I guess it could accept a difficulty first. That will be just like an integer, I think. I suppose I'm not really in the habit of typescripting as I write. Annotating as I write. We'll see. Maybe I'll do some. We'll see how it goes. Not really going to commit to the whole type annotating of everything 100%, but we'll see. I do think that's going to be an int. Most likely that's going to start on 0 and just count upwards, but like being able to pass in will let us test harder difficulties without actually playing, which will be nice. Do we need anything else? I think that's going to be... I mean, difficulty, that's going to kind of translate to the speed effectively. Maybe we're not even going to have a value for speed. Maybe we're going to only have difficulty and then just calculate the speed from that. I don't know. I think I like having both. And I also think I like the ability to be able to set them both when you create the object. So we're also going to have off time. I'll call this LED off time. That is going to be also... I'll call it an int. We might come back and make that a float and have it be seconds instead of milliseconds, but let's start with milliseconds and see where we end up. Alright, and then we're basically just going to set all of those onto our self.difficulty. Okay, there we go. And that's really all that class has. Eventually we might add some like helper stuff. Like maybe this would be cool if it had a function called like advanced level or something, which did all of the changing of the difficulty and the LED time. Maybe actually one more thing we should have is a score. But the score is going to always start on 0, so we're not going to accept it as an argument. Yeah. Okay, we'll start with that. Now we can have async def. Although, isn't there one where it can be like a task? Is this the right one? This is the right one. I was thinking there was one where it would make a class instead of a function, but I guess not. Handling interrupts with keypad, that might be... Do we need that? Are we going to need that? I mean, we're going to be checking so fast. I don't know if we need interrupts. Okay, yeah. That's just... Okay, that's kind of a It's kind of a slightly different take on the one we stole anyway, actually, to be honest. It's not doing the LED part, but it is doing the rest. It is also doing that keypad thing where it's... I mean, this one's a keypad, but it's doing that thing where it's creating it. I really wonder if that's like... Is that a best practice or something? I'm curious about why it creates that, because this is going to be getting called over and over and over really fast. I'm surprised that it's doing that and not just creating it once. This one is doing it that way too, actually. I'm going to do mine different? Is there a reason not to do it? Is there a reason to, like... Let's find out. I'm interested in finding out. I think this feels a lot... In my mind, this feels a lot better. Do we want to put that? We would put that on game state? No, we would put that just as its own thing, I think. I'll just say, like, buttons... What's that? Slower pin faster? Okay, but it's, like, accepting these pins. So ours, this needs a sequence of pins, which are going to be board dot. So D5 is the first one. Doesn't think we have a D5 for some reason. Which board are we on here? Oh, interesting. We don't have board. Huh. What's up with board? Already installed. There we go. Okay, now we know about D5. And then D6, I assume, is the next one. Basically, I went right in a line there. Let me pull up a pin diagram though, just to make sure I'm not. Of course, I also have no idea which button is. Hooked up to which pin. Okay, so 5, 6, 9, 10. Those are going to be our 4. Value when pressed, it does go to false because they connect to ground. The pull goes to high so that they can go to ground when they're pressed. Should be good. That one has a while true. So I guess we might also need like a... I think we might actually need a... Boy, I hate to kind of call it state, but we kind of need a state... Excuse me, a state variable. Because we're going to have a state machine that's like state... player's turn, and then also state, you know, not player's turn, which we're going to try to come up with a better name for. No. Maybe it's another file method that can use... Maybe it's so another file method can use digital I/O on the pin, passing the reference along. That's true, yeah. That's true. Yeah, it would deinitialize every time. It's a good thought. In my case, I won't be using... In my case, all the pins are only used for one thing, so I think I'll be all right to initialize it. My instinct is that the initialization takes some amount of time, I would assume, but maybe it's like very negligible. So we would start, we just say computer's turn, AI turn? Maybe we'll just call it Blinka's turn, because I made the game Blinka Says, which is kind of a play on Simon Says. So we could say like Simon's turn, or we could call it Blinka's turn. And I think I'm just going to actually unplural it. And when the game starts, it's going to be, we're actually going to have, we want at least one more state. State, waiting to start. I'm actually going to bump each of these up by 1. That's going to be the state, because we don't want to start and just like play the first sequence before the player is even looking, right? Like the player should have to press a button or something to officially like start the game, and then it plays the first sequence. Definitely feels like it'd be significant with the keypad, yeah. But maybe not. Maybe it's quick enough to catch a bouncing key. Yeah. Interesting. Maybe at some point I'll do an A/B. I could set up 2 keypads. I could set up one on one button and one on the other buttons, like maybe 2 and 2 or something. Maybe I'll try that out at some point. All right, so we will have monitor buttons, which I guess I'll call monitor buttons. Whoops. Oh, that's fine, I guess. Buttons, that's going to, so I'm not going to take the pins, but I am going to take the game state, which is a game state object. And so inside of here, we're going to have roughly a state machine inside of an infinite loop. If game state dot state, maybe we should call this current state? Current state better? Oh, I did no. Just this one variable right here only. Nothing else. Just this file. Current file. Honestly, I only have one usage of it, so that was all pointless exercise anyway, because I didn't actually finish typing this one. So if it is actually the waiting to start state, then we are just gonna read. Should we do this every time? Yeah, we do this every time. Keys, that is actually buttons. And then if we are in waiting to start, we're just gonna say if any button is pressed, then the game is gonna start. So we can say now if key event dot if key event and if key event pressed. Okay, if key event and key event dot pressed. So if a button got pressed, should I say released actually? I think it would be, maybe I'm thinking released might, because we want to wait until they let go of the button, right? Like when you press a button, I don't know, I feel like the action tends to be when you release more so than when you press down. It feels kind of jumpy if it does it when you press down in a way. I don't know. We'll see if that messes it up though. We don't care about the number in this case, right? Because we're just saying if we're in the waiting to start state, then we don't care what button was pressed. We're going to count it, and we're going to go to the new state, which will be Blinka's turn, because Blinka plays first. And I think I want to make this elif because I don't want to process the logic for Blinka's turn until the next iteration. In this case, it's probably not going to matter. On the LEDs one, though, I think it will matter a bit more. So else, if it's Blinka's turn, we will do some things differently. Actually, in the case of Blinka's turn, I think we just ignore the buttons, right? Pretty sure we just ignore the buttons. I mean, I suppose we could penalize you for pressing the button while it's Blinka's turn or something, but alright, player's turn. You know what? We need one more thing. Well, at least one more thing that we want on our game state is going to be the pressed sequence. And I'm gonna make it, I think, a... It's between a list and a string. I think that I'm just gonna make it a string. No, a list is more proper, right? It's more semantic, I think, because like it is a sequence, it is a string. I mean, it is a list of things. In our case, it will be the list of colors. But I am going to represent the colors as just one letter, like capital R for red, G for green, blue for B for blue, yellow for Y for yellow. So if it's the player's turn, so one thing we need to do is we want to be kind of thinking forward to supporting multiple games. We need to empty this out at some point, but I guess now is not the point. So let's not do that just yet. So we have our pressed sequence. So if it's the player's turn, if key event and key event, we'll say released again. I should probably test that first part here before we get too much more, but let me at least get a little bit here. So if it's the player's turn, if we got an event, if the event was released, now we do care about the number. So we're going to say if key event.key number is 0, which should, I think, map to D5, which in my case is the yellow button. I am going to say game state dot pressed sequence. Can't say plus equals. I need to say append a yellow, a Y. And we'll have to figure out the rest of these shortly, because I don't know which numbers are on the rest of the pins. But we can start with this. So how do we expect this one to behave when we do get around to running it? So it's going to wait for me to press a button. When I press a button, it's going to change to Blinka's turn. And at that point, it will be effectively just an infinite loop of being inside Blinka's turn. Let me just put a print so we can see it happen. That's just going to get spammed over and over. LED, we can keep that for now. We're going to get rid of this because now our button is handled by keypad and it's up there. Inside of our while true, this is all going to be different. Let's nuke all of this. Also, we want this, actually. We want this because we need to let other tasks go. So let's put a sleep there at the end, async sleep. Do we need to keep track of time? No, the LEDs are going to keep track of time. The buttons don't really care about time because the player can't press them that fast anyway. But the LEDs will need to be keeping track of, like, when's the right time to turn off the light or turn on the light in milliseconds or whatever. So, all right, what is this? So we need to make, so inside the main loop here, they actually have async def main. Async, it's kind of interesting. Async def main. So they create an interval. We're going to create a game state. Game state. That's going to take all of our stuff, which I can see easily. This. Oh, you know what I learned? Is it Control Shift O? No. Control O? I? Control Shift I. Will pop up this little context thing, which is nice. So difficulty, then time off, then time on. So difficulty 0, time off. Let's just say, let's start time off. So this is like the time between blinks. Let's start with like half a second. Time on, let's start with, you could just say also half a second for now. That'll be really slow. I imagine we'll speed that up even on the first level. But it doesn't really matter because we don't actually have the LEDs hooked up, so nothing's gonna blink. With that, we're gonna create, oh, that's where our task comes in, I see. Okay, so we're gonna create a button task equals async io.create task from, they call it blink, which is that, so we don't have a blink just yet, but ours is, whoop, I have a Steam. Ours is monitor buttons. Whoa. And then we need to pass that something, the game state. So we'll just say game state. Is that gonna, that's gonna help, that's gonna keep it up. Yeah. That's gonna like be the live object that's changing inside of there. Okay. So we only have one task right now. Eventually we will have two, but right now we don't. Oh wait, we might have a third one for the screen too. I don't know how I'm gonna handle the screen yet. Gather. We only have one, so let's just say button task. Then async io.run main. All right, so we should be in waiting to play, and if I press any button, it should go to Blinka's turn. Start spamming. That did not happen. I pressed green. I'll press yellow because yellow's the only one I know for sure, I guess, that's actually It's still running the old code, because that's what the old code does, is when you press the button down, the light comes on. That's going to be because I don't have auto reload on. No module name async IO. Circup install async IO. Okay. Release. Blinka's turn. Nice. Let me try the other buttons while we're here. Release. Okay. Cool. Alright, all 4 buttons are hooked up. So far that logic is working fine. At some point, let me print this actually. Oh, but we don't have Blinka's turn. Actually, let's print, let's get rid of this. Let's say if key event. So we're gonna cheat a little bit. Like ordinarily we're gonna be ignoring the buttons when it's Blinka's turn, but for right now, in order to test which button is which, we can use some logic here. If there is a key event, then just print it. I'm gonna keep the pass because we're gonna go back to pass later. Oh, okay, yeah, first press got us into play, got us to Blinka's turn, so that was key number 1. It looks like 0, 1, 2, 3, thank goodness. I was gonna be disappointed if it just jumped catty corner. Okay, 0, 1, 2, 3, so now we can add some of these. Don't think it matters if we do if or elif, but elif feels more correct in my head. Should have copied this whole thing. So 1 is green, 2 is red, and 3. All right. We need one more of these because we need to know like Blinka's chosen sequence. Do we want to call it chosen sequence or Blinka sequence? Something else. Let's say Blinka sequence. I'm gonna make a tuple of. I'll be back in a minute. Kirby. Okay. Let's call that something better. Colors? Color sequence, color identifiers, color. Let's just call it colors for now. So one thing we need to decide is when to do the random choice, basically. When to decide what the order is going to be. And We don't want to do it here because when you start the second turn, it's not going to be coming from waiting to coming back. Looks like the stream probably cut out, but recovered itself. Same thing. This one is just going to take the game state. Yeah, I think what we're going to do is... Whoops. We're going to have effectively the same... Oh, eventually we will turn the lights on when you press the button, I guess. Kind of like how it was before. Right now, I'm not going to mess with it. Blink LEDs. Do we blink out in any other state, I think? I'm almost wondering, like, is monitor buttons and blink LEDs the wrong terms for these? I almost want to call this, like, Blinka's turn, or like... Because this is basically going to encompass all the logic for Blinka's turn. And ultimately, the LEDs are actually going to also get controlled from inside of here. So there's going to be some LED control going here. It's almost like this is the player task and this is the Blinka task, the computer, the AI, the opponent of this game. I'll call it, I think, player action and then Blinka action, because the tasks do actually, there is actually a task object down here. So we'll end up with a player action and a Blinka action. And possibly something else too, but we'll see. So if it's Blinka's turn, here I think what we can do is if game state dot Blinka sequence is empty, or should we set it to none? No, let's just do empty. If it's empty, then we're going to add something to it. The thing we're going to add to it is random.choice of the colors. And we're going to do that for I in range game state difficulty. If you do range 0, does it actually loop? You might need to start on difficulty 1. Oops, I did 1. Then I just put I. I printed 0, but what if you do 0? It's gonna do nothing. It's nothing. Okay, I guess we could just say difficulty +1. It just probably makes more sense to start it on 1 though. Okay, so we will loop once for each difficulty. Eventually, maybe I'll change the logic to say, like, maybe it's not a one-to-one connection. As you could probably guess, it's been a very long time since I have played the actual game that this is inspired by. So in my memory, the way it works is it's +1 blink every round. So like each round as it gets harder, there's one more to the sequence. It starts out as just one, the next round's 2, and then 3, and then 4, and then, as long as you can manage to actually remember them. Which is what I'm going to aim for now, but it might be nice to maybe have a separate like setting or a separate way to play or something where maybe it's like, only every 5 levels it increases by 1 or something. That way it lets you like practice more for each level, if that makes any sense. All right, so that should fill our sequence with a random set of colors. And we're only going to do that when the length of the sequence is 0, inside Blinka action, on Blinka turn. So then, whenever it's time to change turns, whenever it's time to generate a new set, we'll just set that sequence back to empty, which will trigger this part of the code to run again. All right, and then what's next? I think the next thing we do is sequence current state. We need a self dot Blinka sequence index, I'm going to call this. So the first thing we are going to do is turn on the LED for the choice, but we actually only have one LED set up. Why don't we make a dictionary of these? I sure do like me some dictionaries. Let's call this LEDs. We can key this with the strings we're using. So yellow, green, and then red, and then blue. And that should just be counting up, I believe. I also chose 4 pins in a row for these. I used analog pins. Eventually, maybe we'll do some fading or something fancy, but for now, I'm just going to go on-off. But I did pick analog pins with the idea being like I could give myself that opportunity in the future to do maybe some fading or something like that. Okay, so now those are going to be all there for us. We do still need to set the... I think you could do this here, actually, though. Can you? No, maybe not, I guess. In only, okay. That'd be cool if you could set direction from there. No matter, we'll just... We could loop this, actually. This is not relevant to us anymore. For color in, color shouty, we will go LEDs, color... I guess we could loop over LEDs too. Does that work, or is that going to give us the keys? I don't know. Let's just do the colors. That's how my brain works anyway. LEDs color, and then we'll say dot direction equals output. All right. So turn on the LED for the choice that was made. So we go, put this at the top. I don't think it matters, but it makes most sense to put these together, I think. And in fact, I think it even makes sense to put it up here. All right, Blinka sequence. Maybe I should not call that Blinka sequence index. That's going to get very wordy. Should we just call this index, or see how that goes. Because we don't need the... Do we need the... I don't think we need an index for the player one. Because for the player one, we're going to be... Like, we're not iterating over it, basically. So we don't care about the index. LEDs, game state, Blinka sequence. No, we changed it to index. Well, but we still need that, and then we need game state index. There we go. Okay, so get the digital in out, get the LED object. On that, we're gonna set it to true to make it turn on. And then we basically need to wait. Basically need to wait until it's time to turn it off, which I think I'm not going to be having the lights ever on. Like, I'm never going to be having two lights on at the same time during Blinka's turn. So I'm thinking we just go async IO sleep. That is taking a float. So I'm guessing that's going to be seconds. I don't actually know though if that's... How's it going? Friend on Twitch. Sorry, Negvorsa. I get a good look at your name just yet. Yeah. Oh, there it is. Okay, sleep for T seconds. There is T seconds. What board is that? The microcontroller is a Feather S3 TFT. And then it's connected, in this case, through some slats in the box. It's connected to a proto breadboard that's on the bottom side, which has some little jumper female headers that the buttons are plugged into with some alligator jumpers. If you are interested on the inside, if you're interested in the circuit, earlier in the stream, I had it flipped over. So if you check the VOD on Twitch or YouTube, and scroll back to like the first couple of minutes, I had it flipped over and I had the light on so that we could see in there a little bit better. So that is seconds, but what we have is milliseconds. So I'm going to say game state dot, what did we call that? LED, we want on time, actually, on time, but that's in milliseconds. So we're going to divide it by 1,000, because that's going to give us the number of seconds. Yeah. Okay. This is yellow. Coroutine sleep is... Oh, we need to await. Yeah. There we go. Okay, so we turn it on. We wait for however long the on time is. Then we turn it off. And then we wait for however long the off time is. Await. Yeah, the Feather TFTs, I really do like this form factor, the Feather TFT. It's a really nice device for, in my case, just like general purpose testing and development. I do a lot of testing, reviewing of library code and stuff like that, and it's a great device because it's small, but it has a display. It also has a stemma connector for connecting other sensors. The ESP32S3 is pretty darn fast and snappy as far as processors go. It's got plenty of RAM. It's got plenty of file storage. It's kind of like just a really nice generalized device for my purposes, at least, which are certainly not necessarily the same as everyone's. Although in this case, it's not, obviously not, you know, it's serving a way different purpose as embedded inside this game. But I actually have another one of this exact same Feather on my desk here that I'll grab and use for all kinds of other stuff too. We want to sleep for the off time. And then at that point, I think we just loop, or, well, we can change the index, game state dot index plus equals 1, and then we need some logic that knows when it's at the end. I never used ESP nor coding in Python for microcontrollers. Oh, nice. Okay, yeah. If so, I'll give you the intro spiel. Yeah, feel free to ask questions or anything if there's stuff you're interested in. But CircuitPython is the thing I'm using, which is a fork, a friendly fork of MicroPython. You know, we're not trying to like fight with MicroPython or anything. There's two different, kind of have two different use cases. But CircuitPython is a fork of MicroPython. And like the high level 50,000 foot view of what it lets you do is when you have these microcontrollers plugged into your computer, they show up like a thumb drive. So I'm on Linux here, but I just have CircuitPy, which is the actual microcontroller connected, just like a thumb drive, and then that code.py file right there. You just write your Python. That's exactly what I have open here. You can just write your Python code in there, save it, and in the default setting, as soon as you save it, it actually restarts the microcontroller and executes your code. In my case, I have the auto reload turned off right now just to make it easier to develop, but kind of the high level view at it. If there's any other things of interest or questions or anything like that that you have about the platform or anything specific, I'd be happy to answer them. Have you used, I'm guessing, like Arduino type stuff more frequently, or what other kinds of microcontroller development have you gotten into? If that's something that you actually have done before, I'm always curious what other folks are using for stuff. I will say too, like it does cost resources to like it's interpreting Python inside that microcontroller, so it does cost resources. If you have like a time critical thing or something like that, where like you need to very precisely control, you know, microseconds or something, then Python on the microcontroller is not the way to go. But if you're doing something where the intervals of time you care about just are not that big, then it's really, really great for iterating, writing your code super fast, getting your thing up and going as a proof of concept. C, C++, Rust on AVR, STM832, CH5058-2F, still learning. Nice. Cool. Yeah. So the CircuitPython core, the program that runs on the microcontroller that actually interprets the CircuitPython code, that is actually a C program. So there's like a whole repo where it's and MicroPython as well, since CircuitPython is a fork of that. But I dabble in C only. I never been necessarily trained or learned C that much, but it's like sort of similar in some ways to languages that I have used. And so the more I just kind of flail around inside of it, the more I learn. But Java and Python are my two fortes, although I do a lot of web development these days as well, with HTML and JavaScript. We want to check if the index is at the end, basically. So if index is greater than, we're going to start on 0. We're going to increment it to 1. So we want to say if it's greater than or equal to the length of the Blinka sequence, then we know that we have reached the end of the blinking. And at the end of the blinking, what we're going to do is a couple of things. We need to set the index back to 0 so that we're ready to blink next time. We need to empty out the Blinka sequence so that when the time comes, we will generate a new one. Is there like a dot empty? A remove? Clear? I think that will empty everything out, right? What else? We need to change the state. So our state will change to the player's turn. You'll scroll through the entire document to prevent a couple of characters of typing. Anything else? So we reached the end of our sequence. What else would we need to do at that point? I think that's possibly it. We reset that to 0. We empty out the sequence. We change to the player's turn, which means then our Blinka action will be doing nothing until we get back to Blinka's turn. And with that allowing us to get to the player's turn, it means that we could also start actually building up the pressed sequence. Maybe we should call this the player sequence instead of pressed. Since we have Blinka sequence, player sequence, we also have Blinka turn, player turn, I think makes a lot of sense. Well, player turn we have obviously, but player sequence, I mean. Let's just save this file again. We don't need to go anywhere else. Is that okay? Oop, let me see. If that's okay, game quick summary. Yeah, for sure. Sorry, I don't know if that was loud. The game that I'm working on right now, I'm calling it Blinka Says, and it's basically just like a re-implementation of the game Simon. If you've ever seen the kind of like children's... Is that a Parker Brothers one? I don't know. It's like this kind of game, basically. And the gist of it is you turn it on and you go back and forth between like what I'm calling, in my game, I'm saying Blinka Says, which is kind of a play on Simon Says, which is what the Simon in Simon, I think, comes from, to the best of my knowledge, but maybe that's wrong. I don't know. It could just be a dude named Simon at some point. Or maybe it's the other way around. Maybe that's where we got Simon Says. I don't actually know where that term came from, but they're tied together in my head. Whether or not it's actually true or not, I couldn't say. But you go back and forth between the computer's turn and the player's turn. When it's on the computer's turn, it will blink the lights. Inside each of these big buttons, there's a light that can turn on and turn off, so it will blink the lights in a random order. So the first turn, it might blink the blue light. And on turn 1, it will only blink 1. And so it blinks blue, and then it turns to the player's turn. The player's job is to replay the same sequence. So on the first turn, if it blinked blue, your job is to press the blue button. And that's all you got to do for the first turn. After you do that successfully, then it goes to the computer's second turn, where it's going to come up with a new random sequence. So this time, it will be 2 instead of 1. So this time it might be like, blue-red. And then it's back to your turn, and you have to say blue-red. You have to push blue and then press red. And it keeps going like that, turn after turn after turn, getting one step harder each time. So the third round, there'll be 3 lights. The fourth round, there'll be 4. And it just keeps counting up like that. And you have to keep trying to push the same sequence that it lit up for you. Now that I'm actually saying it, I think the real game... it might actually progress. I think it might actually be like if blue is the first one, then the second one will be like blue something else. So like if blue is first and then blue-red is next, I think the third one, it might be like, blue-red-blue or blue-red-green. Like I think it might actually just always reuse the last one but add a new. Whereas actually the direction I was heading in my code is we choose a random one at the start of each round. I think I like that better. I'm sure there have been, I know for a fact there have been just loads and loads of these different things. I'm sure there has been one that's been random each round. That's only one of the, so that's, yeah, the original device that had multiple game modes. Yeah. Named after Simon Says. Whoa, I had never heard of... What is that? Oh, okay. It's made by Atari Company, but it doesn't plug into an Atari, does it? This doesn't plug into an Atari, does it? Didn't they call that Atari? No, okay. So this was like before Atari became Atari, basically. I mean, they use the name, but I think of them as the entertainment system. Crazy. It doesn't actually say the part that I'm interested in. I'll have to maybe, we could watch, I'm sure there's a YouTube I'm gonna keep trudging forward with the random though. I think it will make it a little bit harder. Like when it reuses the same sequence each round, it's a little bit easier because you're always just adding one to the end. Whereas if it's truly random each time, like you're having to remember a whole new sequence. So that makes it way harder. So maybe we eventually will add a different mode where it's like in one mode it's progressive and then in this mode it's random. But I'm gonna do the random mode first. Because I know some of my code is already written for that. All right, where did we end up here? So we're going to the player's turn. That's going to make this thing build up. Let's just go ahead and print this at the end of this. Print the game state.player sequence. And we're not going to bother with anything else yet, but this should get us to the point where we press a button to start the game. Blinka will choose for random sequence and then blink it, and then it will go to our turn, and then we will be able to keep pressing buttons and keep building up a sequence. And then, nothing else will happen because we don't have any other code, but that will get us further than we were before. Invalid syntax. We could probably close this one now. 59. Did I not save? Maybe I didn't save. I don't know. Okay. Yeah, I didn't save. Looks like. Okay, so first button press is just to start the game. But after I start the game, it is going to blink, and I got to be watching. So I'll press blue to start, and then we'll watch for the blink. Didn't actually happen, though. Okay, there we go. Oh. Wait. No, it worked, but... Okay, so the first let's add a print statement when we start the game. So we start in waiting to start when we press the first button. Easy for coding too. Yeah, I think it's a good game for it's like a middle ground between like it's fairly complex, but it's not super duper insanely complex. And the fact that it's kind of just 4 different buttons that all are effectively the same thing and behave the same way. They're different colors, obviously, but they don't like fundamentally do anything different. It's a lot of good like opportunity for learning how to break programs down for sure. Your for loops and your data structures that can kind of make it easier to handle. Yeah, ultimately, I will be making a learn guide for this. I'll show you if you're interested in this sort of thing. Maybe the other one that I made before will be of interest to you. But ultimately I'll be making a learn guide the same as I did this one, which is this is kind of a different game, but it's built into the same cardboard box, basically. Not the exact same one, but a box of the same size and everything. This one was a one-dimensional Pac-Man game, which you can find on the learn system. I don't know how much you know if it's, but it's over at learn.adafruit.com. Link, yep, you gotcha. There is no guide for the new one yet, obviously. Like, I'm just writing the code now. So I'll write the code first, and then once that's done, yeah, for sure. Once the code is done, then I'll get into the guide. I find if I try to do the guide and the code at the same time, I'll end up, like, writing stuff in the guide to some code that doesn't end up being the way it works. And then it's like I go back and end up redoing it, but... All right, here let's say starting game. That way we know, that way there's actual feedback. And then at the end here, let's say print player's turn. Okay, so starting game works fine, but we never see player's turn. Probably I messed, well, no. Yeah, I don't know. One second, I gotta run to the restroom though, so I'll be back in a minute. All right, so why do we never go forward? So when we print starting game, we also change to Blinka's turn, which I never added it to down here. Yeah. Let's change this to player task, right? Because we ended up with player action. And then Blinka task. And then we do pass both of these, and then also we renamed it, so we can... Oh, I didn't press it all the way. Oh, or it's just not working anymore. It's not working anymore. We don't have a sleep inside of the Blinka action, therefore it's not letting the other actions. Well, we have this one, but we need another one. We need a sleep 0 inside of here somewhere so that other tasks will be able to have a turn. Otherwise, we'll get an infinite loop, which I'm pretty sure is what we were getting. There we go. Okay, starting game. And then now it's player's turn. I will be real honest, I didn't pay attention. I don't actually know which one blinked. Okay, this time red blinked. All right, so on player's turn, it's just gonna print whatever we press. So I pressed 1, we got an R, a B, a Y, a G, and I could just Y. We'll just get new ones of those each time. So now, in order to determine if the player has, beaten this level, like defeated the level, we will check the sequence against the Blinka sequence. Can you just compare lists? I was thinking of adding more touch buttons in one row as a piano with sound effect. Will be maybe like a music game. Oh yeah, that'd be pretty sweet. Yeah, I will say that learn guide system, the thing that I linked to, that not Python, but the Chomper game is inside the learn guide system, which has loads of other stuff. If you click on Explore Learn here, or if you search here. Especially I happen to know there's lots of stuff for music. So if you search up music or you search up piano or anything like that, if that kind of stuff is interesting to you, I've like messed up the overlay somehow. Let's refresh. There we go. The old cat piano, JPs. There are all kinds of other guides that do all sorts of music stuff. It would be cool. I thought about a speaker. I may still add a speaker. Still add it. Right now I don't have any speaker on it, but it would be kind of cool, wouldn't it? It would be kind of cool to have a little speaker somewhere. Sure. I mean, something like that would be pretty easy to connect, I guess. Maybe I'll end up adding a little speaker. It would be cool to be able to do that's because that is part of the original game too, is it plays a certain note. It plays a tone on each button, and each button is a different tone. So like earlier I was saying the buttons aren't functionally different. That is actually one of the differences in the real game, is they do play different tones. So you could kind of play like blind, so to speak. You could play by ear only if you would want to. But so in Python, can you compare lists? Like if I have like R, G, and then like B, Y, are they not equals? And then if they were actually L1, if they were actually equal, would they be equals? Nice. And like if you had another one, they would be back to not equals. Okay, cool. I was assuming that's how it behaved, but I wanted to make sure. Zero experience in Python. I have a fair amount of experience at this point, but there are definitely still things where I don't trust myself. Like, I was pretty sure that's how it was, but I didn't trust my gut instinct to actually be correct. There's some stuff like that where I'm like, I think that's how that is, and then I will code around it, just assuming it's true, and then later on realize I was wrong. All right, so that should make it actually super easy. So whenever we're pressing the buttons, we're building up our sequence, and we're going to be able to just say if the game state.blinka sequence is equal to the game state.player sequence, then they have like beaten the level. And so what all happens at that point? We give them a score. I'll just say plus equals 1 for now. Eventually we might spice it up with the score, like maybe it gives them more than 1. Maybe it's like time based, and if they do it quicker, they get more. For right now, I'm going to keep it super duper simple, and score is basically just going to be a proxy for level, essentially. We get a +1 score. We're going to be changing states, so we're going to go game state, current state will be changing to Blinka's turn. Also, we're going to say elif the length of the player sequence. If the length of the player sequence is greater than or equal to the length of the Blinka sequence, we know that they have lost. Actually, can you do starts with? I think you might be able to do starts with. No. Okay. String has starts with. So I was gonna say we could actually like if they were supposed to enter, you know, blue, green, yellow, but they actually enter red on the first button press, then they, you know, like they're already wrong. So the logic I'm writing would not treat them as wrong until they've entered the third thing. But honestly, we should treat them as wrong as soon as they press the wrong thing. Okay. I think, let's comment that. I think we're going to delete it, but to start with, let's actually do this differently. Let's say for color in, so let's loop over the player sequence and also the index. Enumerate. Loop over the color and the index, and then for each one of those, we're going to say if the, let's call this the player color. So if the player color is not equal to the Blinka color effectively, so game state, Blinka sequence, index. Let's see, if I'll do it, use just one sequence array, each press I'll pop and check the value and stop in the first mismatch. Use just one sequence array. Oh, I see what you're saying. Yeah, instead of comparing between two arrays, you just have one, and then as the button gets pressed, if it's equal to the first item, then remove the first item. Yeah, I think I like that. Thank you, by the way. That's always one of the coolest things I think about streaming. Streaming work on programming is getting ideas from folks who are watching. So thanks for watching along. Thanks for offering up that tip. I appreciate it. So that's just going to be sequence now. And then this will work differently. Basically, this would be the new logic here would be like if this is empty, essentially, I think. Let me hold that for a second, though. Okay, so realistically, we don't actually need to append these anymore. These were the player sequence. We don't really need to append them. Instead, we need to just be checking if YGRB. Okay, those are in the right order there. We just need to be checking if it's the first one, and if it is, then we remove it. So if choices colors key event dot key number. So if the button that was pressed is equal to the first one in the sequence, then remove the first one in the sequence, which I think we need to do game state dot sequence. Zero. If it matches the first one, then remove the first one from the list. All of that goes away. And the logic here now is basically if the length is down to 0, then we know that they won the round. Which is where we will do this. So then on Blinka's turn, when we generate the sequence, that would just be sequence. That is on. That's actually convenient because it also puts itself back to empty, which is our logic in here. One thing that might be nice is we might want to build in a little bit of extra time, because I feel, so what will happen now is as soon as you release that last button, that's going to turn it to Blinka state, which will then instantly create the new sequence and turn on the first light. It might be nice if there was like an extra LED off time, maybe before it turns to Blinka state, so that you have a little bit of time to get ready for it. But let's see how bad it is. All right, so if that's on 0, we loop to difficulty. We are appending those. We do our blink. And we would need to, well, this is this part can still be the same actually. We say if This part we, whoa. This part we don't need. In fact, I was doing this in the wrong place anyway. This shouldn't be inside the blink action. It should have been inside the player action, I think. But anyway, we have a different logic for how it's going to be anyway. So if index is greater than equal to sequence, we know we've gotten to the end of our blinking. So we will reset index for next time. We don't actually want to clear the Blinka sequence, though, because now we're only using one sequence, and the player action will need to use that same sequence. So we don't clear that. We do still change the state to player turn. We can still print that as fine. Okay. That part should still be the same. Okay. I am sure there's some reason why it won't work, but I don't see it off the top of my head. So let's run it and see if we actually make it to working. All right, so it's waiting for me to press. All right, so green is the first one. It seemed like it just chose green again, and it also seemed like it only did one. Oh, I did not increase the difficulty. Whenever we increase the score, we should increase the difficulty. I am going to keep them separate. We are doing like a 1-to-1 right now, and so technically they could just be the same variable. But ultimately, I think the score will get a little fancier with, we'll do some, you know, bonuses and some bigger numbers. We'll crank the score up a little bit to make it a little more interesting. Whereas the difficulty is going to always just be incrementing by 1. All right, red. I wonder, it feels like there's a gap because it's waiting for the LED off time. Maybe we should not wait for the LED off time on the last one in the blink sequence. Did that not register? Ooh, it's messed up. Turn. Let's go back to printing here. Yellow. So it seems like it blinked yellow again, but again, it also seems like it only blinked one thing. Let's print the current sequence. Okay. That time we definitely got yellow then blue. Let's print the full sequence at the time we generate it for now, actually. Just for debugging, we'll turn that off, probably, if we're actually playing. So yeah, let's just print that. All right, let me see if this works, though. Oh, interesting. Wait. Okay, for one thing, we want else. For L, we should have else here. I don't know. I'm just gonna put player lost. Eventually, maybe we'll have lives, or I don't know. We'll do something, but why did that turn out to be an R though? It definitely blinked yellow and then blue, I thought. So green. Green, so that says green red, but we actually got green blue. Are those just swapped? Okay, let's make it so when you press the button, we turn the LED on that we think it's supposed to be mapped to, because that will tell us if we got them wrong. Yeah, I'm thinking they must be swapped. But one question is it only the LEDs that are swapped, or is it the buttons too? Or is it maybe just the buttons? So let's say when we're on the player's turn, we are, whenever they press, so let's say if key event dot pressed, then let's light up the LED. Let's light up the LED that we think it's supposed to be. Except we are on released here, so we can't do that this way. We need to do this here. So if it's pressed, then turn on the LED. If it's released, we can turn off the LED. Is also when we will print the event, the current sequence. If it was equal to the first one, we remove it. If it was not equal to the first one, then they lose. If they're down to 0, then it's back to Blinka's turn. Blue? Untype has no pressed. So it says R here, but it did blink blue. Line 52. Oh, okay. If key event and. So when there was no event happening, then it null basically. So we got yellow for the first one. It said yellow red. Let me hold it down more. So yellow is on. Nice. Okay. But then it does say red. So now so will blue turn on? Nope, red turns on. So right now when the blue button is pressed, the red LED is turning on. That's going to get me to player lost, but player lost doesn't actually do anything, so I can test this one too. And those are totally swapped. So when okay, so we need to either swap the button pins or the LED pins. I'll just go with LED pins, I think. Yellow. Yellow's working. So then we got green, green, but I'm actually going to press blue, which now lights up the correct one. And then red, which now also lights up the correct one. Okay. All right, green. We had a green red actually, yeah. So that was really fast between when I let go and then it turned green back on. Was like, it was really hard to kind of tell. Let's let's add another wait when after we generate the sequence. So inside Blinka action, when that was empty and we generated the sequence, we print it. Let's also go await async IO sleep. We'll just say like let's just use the LED off time, I guess. And then one more thing, actually, let's say we want to like not blink on the last one. Let's put this here. Let's put this after that, and then let's say if GameState.index is less than the length of GameState.sequence. So, oops. So we don't want to wait for the off time at the end of the blink sequence before the player is allowed to start pressing buttons. The player should be allowed to press buttons as soon as the last light of the blink turns off. So that's what this will do. But after the player has entered their sequence and now it's back to Blinka's turn, before we had no waiting. We just went from as soon as the player releases the button, like literally the next instant, Blinka was turning on the first light, which sometimes could be the same light that the player just got done, just got done releasing. Now, though, we will wait for the LED off time after we generate the sequence before we turn the first one on. So we kind of like got rid of one gap, but added another gap. I didn't actually, did the blink work? I didn't actually catch the blink. I'm not sure if the blink worked. Yeah, no, something's wrong now because the lights aren't actually turning on either. Okay, something's definitely broken. How I broke this. Okay, let's get rid of this one for now. Maybe we don't want this for the moment. Let's just take this one. Sure, I did something wrong. Yeah, I think it's getting stuck in there somehow. I don't know for sure. Let's just put that back. Try this again. Oh no, what have I done? Did this messed it up? Messed it up. That's odd. As soon as I have that there, the LEDs do not work at all. Well, right now, right now there would be no LED actually, because in the waiting to start, I don't turn the LED on. But the LEDs don't work, because now the green one should have blinked and didn't, and the yellow one should turn on and doesn't. But we're not like stuck in here because we're not printing this over, like that's not spamming. So why would this sleep completely wreck the LEDs? Oh. Okay, I get it now. We told it to sleep for way too long, basically. 500 seconds. So it was just staying asleep the whole time, which then meant that basically Blinka never got to take a turn, is really what happened. It generated the sequence, then it slept for longer than I was patient enough to wait for, and then I restarted it. But if I would have waited for 500 seconds, then it would have blinked once and gone back to working, except for it would have slept another 500 seconds at the start of the next round. Okay. Whew. I'm glad that I figured that out, because that was very bewildering for a second. There we go. All right, so red is on. Go red. Blue, red. Red, blue, green. Red, red, yellow, blue. Blue, red, green, blue, yellow. Blue, red, green, blue, yellow. Blue, blue, yellow, red, red, yellow. Oh, I messed it up. Double red. The double red got me. Yeah, well, I wasn't actually looking, but yeah, I am kind of in cheater mode with it printing out there. But I lost anyway with my double red. All right, that's pretty good. I'm pretty happy with that. I wasn't sure how the async IO code was going to turn out, but I'm actually pretty happy with that separation of, we have kind of like one task for the computer's actions, the AI's actions, one task for the player's actions. I think that's a pretty good separation logically. This did end up being easier. Thanks again, by the way, for the sequence tip. Get rid of that. Cool. Okay. I think I'm gonna stop there for now. Get some lunch and fill out my stuff for the meeting. So thanks for watching along over on Twitch. Nagvorsa, appreciate your input and just hanging out while we stream. Feel free to follow if you are interested in this type of content. I usually stream on Saturday mornings working on CircuitPython stuff. So if the microcontrollers or the Python stuff is interesting to you, Saturday mornings at 10 a.m. Central Time is when I'm usually around, although I do sometimes pop up on other days, such as today here on a Monday. I work on CircuitPython all day Monday, so that's kind of like the only weekday typically where you will catch me during the day streaming CircuitPython stuff. Thanks also, Tyeth, over in Discord. Thanks to anybody else watching. And if you'll be around for the meeting, then I'll see you, or I'll talk to you at least here in a couple hours for the meeting. Otherwise, next time I'll be back is on Friday for Deep Dive this week. I'll be filling in for Scott on Friday the 14th, so I'll be around over on the Adafruit channel for Deep Dive on Friday, and then I should be back on Saturday, I believe, at the normal time, 10 a.m. Central Time. So thanks again. Have a good day. I will catch you later.